Hello once again. So in this tutorial we will see how to create a node editor. As you can see, this is our node editor window where when we do the right click we will have different nodes over here. For example, we have our input nodes, our output node, a calculation node, and a comparison node. Now each input node will have some different properties. For instance, our input node will be either a number, which allows the user to put to hardcode a value, or a random, we will see how to fix that, or a random type, which will give the user the ability to give a value, a minimum value and a maximum value, and when the hit generate, it will actually return a random number. We can also have a custom title. We can do whatever we want. We can make curves so that we see the connection between our nodes. We can delete our nodes. We can, if we have two input nodes, we can either use them to calculate a node, and we have addition, subtraction, multiplication and division, and we can have another node, another input node, and pass that calculation node into a comparison node, and we have a greater, less or equal, and in the end we can get the result. So where can we use this? If we want to make an asset or help our team without having to mess with scripting, we can visualize a lot of stuff, and so our team can work together without having everybody to have knowledge of scripting. So let's say if you played any RPG, let's give a value of to attack or to hit, let's say, and our character had a 50 or 65 to hit, and we add a bonus from an item. Let's say we give him a 10. We pass it through a calculation node. We can choose what we want to do with our two inputs. I want here to be the addition, and after that we want to pass it through a comparison node, but our comparison node, the second input of our comparison node will be a random number between 0 and 100, and we pass it to the comparison node, because 65 and 10 will give us a 75. So that means our character has a 75% of chances to hit a target, and we pass the result and give us, if it's greater than the random number, it returns true. if the percentage is lower than, if the random number is higher than the percentage our character has to hit, which in this case is 75, then it returns to false. So in a later videos we will see how we can utilize further this. This will focus mainly on all the functions and utilities our nodes can have. So let's close this now, and let me just delete all this stuff so we can write them from the beginning. We're using Unity 5, but it's going to be the same with Unity 4 also. So let me first create every script we want to use. First thing, we will make a base node. Second, we will call it base input node. Next, we will make an input node. Next, an output node. Next, a calc node, which is short for our calculation node. Next, a comparison node. And finally, our node editor. So now that we have all our scripts created, let's go and actually start writing our scripts. So let's open up the base node. Let's just wait until mono behavior opens. Mono develop. Let me zoom in so you can watch. First off, we will need the Unity editor namespace. Second, we want a class to be an abstract class, and we don't want to derive from mono behavior, but we want to derive from scriptable object. We use scriptable object because in the future we will need the messages that Unity calls on scriptable objects, such as on destroy, on enable, and stuff like that. Now, the first thing we will need is a place to store our window rect, which is a public rect window rect, and we save the location and the size of our window. We want to have a public boolean that it will help us indicate if the descendant of the base node has inputs or can only be used as an input to another node. We need a title for our window, which we will simply call window title and just put 2 quotes in there. Let me just delete all this because we don't need them. Now we need a public virtual void, which we'll call draw window, and this will draw the window of the base node, and we have it virtual because it's going to be implemented by each subclass of the base node. And of course we want our window title to be equals editor GUI layout dot text field, just call it title over here, and pass our window title. Now we want another public abstract void which we'll call draw course, and this draws the course from the inputs of these nodes, and this is an abstract class because it must be implemented by each subclass of this base node. Now, next thing we need is public virtual void set input, and to this we will pass our base input node, which we'll call input, and vector2 click position. Now this, it is used by the subclasses nodes that has inputs, and it's called when the window is clicked through during a transition. We make it virtual because it's optional for nodes that don't have inputs, and we pass in the method the node to be used as input and the click position of the mouse. Next, we want a function that will help us when we want to delete a node, which we make it a public virtual void node deleted. We pass the base node, we simply call it node and put the brackets. And next we want another public virtual base input node. We will call it clicked on input, and we will pass vector2 position, and this will return null. Now this is called when a click happens on a window and returns the input that has clicked, or if it doesn't, then returns the null. So this is it for our base node. Let's go to our base input node now. So, few changes we need to do over here is, instead of mono behavior, we want to inherit from base node. We will use this class in every node that can have an input. So we want to have a public virtual string, which we will call get result, and for now it will return a string which is say none. This will return us the return of the node, the result of the node, and we need to pass our draw course. Since it was an abstract class, so it must be implemented in all subclasses that derive from the same superclass, from the same base. So we have our base input and we have our base input node. The next thing we will do is write a script for our input node. This of course uses the Unity editor namespace, and this inherits from base input node. Let me delete this. Let's fix this. So we want to have two types of input. So we will make a public enum, we will call input type, and inside arenum we will call it number and randomization. And of course, because we want this to change, we will make a private input node, input type, not node, input type. The number is going to be when the number is hard-coded by our user, and the randomization is when we want to take a random number from the range the user gives. So let's write variables for a random type, and which we'll call a private string random from. We'll give it an empty value right now. We want another private string which we'll call random2, which is also empty right now, and we want another variable which we will use when the user hard codes the input. So we want to add a default value to our input node. We'll call window title equals input node. Then we pass our abstract class, which is draw window. We want to have everything from above, so we write base draw window, and we want to start adding some more stuff the user can do. So we want to have a enum pop-up so the user can choose the type of the node, and the way to do this is by input equals, we cast it as an input type and say editor GUI layout dot enum pop-up, and we pass it a string that it's help the user identify what this is, and we pass the input type, the variable of our input type. Next, we want to start writing the cases for our inputs, for our input types, and we will say if input type equals input type dot number, we will add a text field and we do this by saying our input value equals editor GUI layout dot text field value input value, else if input type equals input type dot randomization, we will add two text fields, one from random from, and we will say editor GUI layout dot text field from, and we pass a random from variable, and random2 equals editor GUI layout dot text field we pass the random2 variable. So because we don't want to start calculating random number every frame, because it will never keep one value, we will actually take a random number every time our user clicks a button. And the way we do this is we call if GUI layout dot button. We give a name to our button. We just simply say calculate random, and we will call a function which we haven't already set up. So select it, right click, refactor, create method, use the arrow keys, go to the end of our script and hit enter. Delete the stuff that was automatically inserted. Before we start our calculate random, let's pass our abstract class our draw curves, public override void draw curves. And now let's go into our calculate random. We make it a private, and now we need a float r from, we initialize it with 0, we need r2, we initialize it with 0, and we want to do float dot try parse random from out r from, and float try parse random to out r2. Now try parse tries to make a float from an integer, tries to make a float from a string. We say try because if the player has invalid numbers, which is capitals, which is stuff that are not numbers, you know, ABC, how you call it, I forgot. Okay, so this will return. So if the player said wrote in a string something like this is 10, it will actually try and find what is a number from the string, we pass it, and return that number. So after that, now that we have our floats, we want them to be cast as integers so that we don't have decimal values, and we say the way to do that is by casting it as an integer and we multiply it by 10, and round 2 is going to be the same. R2 multiplied by 10. After that, we calculate the random, and we want integer selected, which equals Unity engine dot random dot range rand from rand to +1. We do +1 because we want to take the exact number the user has inserted. Otherwise, so let's say if the user inserted 1 to 10, it will take a number, a random number between 1 and 9. So we just add 1 and we are done with it. After that, we return the integer to its float state by simply division with 10, and we pass our input value equals our selected value, and we pass it as a string by dot to string. After that, we want to pass the abstract class of get result, and this, don't need this, and we pass the abstract class of get result, and we say return our input value to string, because this is a string. Let me check quickly that everything is okay. Alright, so that was our input node. Let's open up our output node. So we need once again our Unity editor. We need this to inherit from base node. Let's delete this. Let's make this go down. We want a string so that we can visualize a result, and we add it here. We give it an empty value for now. So the output node has only one input, and we say base input, private base input node, and we say input node. So the only thing can be attached in our output node is an input node. We want another variable so we can store the rectangle of our input node. Once again, we want to pass a title, a default title, and we say we use our constructor, and we will say our window title equals output node, and we say has inputs equals to true. After that, we pass our public override void draw window. Once again, we pass whatever is on the base class on the draw window, and then first off we want to check for event. The way we do this is by calling event e equals event dot current. We want a string to help us visualize if there is an input node attached, and we just call it input1 string input1 title. We give it the default of none. So if there is an input node, the input title equals our attached input node dot get result. So this will take the value of our previous of the attached input node. So now that we have our previous the result from our input node, of course we want to visualize this, and we say GUI layout dot label input 1 plus input 1 title. So now we will make a check to see when the window is repainted, and we store our input node rect, or how was it? Input, I've missed a taf over there, and we store our input node rect, and we store there our last rect, and we do this by calling GUI layout utility dot get last rect. So now that we have this, of course we want GUI layout dot label result, and we pass the result, and we have this. So we need to pass once again our abstract class of draw curves, and if we have an input node, so if there is an input node attached, we draw a curve from the input node to this node, and the way we do this, we use a rect, simply call it rect, we store our window rect, we take the x of our rect and add our input node rect.x, we take our rect.y equals input node rect.y plus our input node rect.height division by 2, so that we get our center, and we set the size to be equal to 1, and we set the width to be equal to 1, and the height to be equal to 1 also, and we say node editor dot draw. Oh, we haven't added this, so just comment it over here, and we say our node editor, we pass our draw node curve, and in there we'll pass our input node dot window rect and the rect. We will make later this function, or actually we can do it right now so that we won't have same problems. Where was it? Yes. So for now, let's delete all that. Let's add public static void draw node curve, which is, and pass it a rect we call start, and a rect we will call end. For now we will leave it at this, but we're gonna change the inheritance to be to editor window, we want to add the Unity editor namespace, and because we will be using list, we want to also add the generic. So that's it for this for now. Let's go back to our output script and continue with what we have. So we have our node editor. So after that, we need to pass the node deleted, which takes base node, and we will say if node dot equals input node. So if the passed node is the same with our input node, we just make our input node null. So that means if a node is deleted, we pass it from every node and see if the deleted node is the same as the attached input node, and if it is, we delete it. After that, we want to pass our public override base input node, and which we will say clicked on input, and we pass a vector to position. So this is going to be called every time the click happens inside the window. We want a return value, which is going to be of base input, and we will call return val equals null. We want to convert the global input position to local space, and we do this by subtracting our position minus our window rect.x and our post.y minus equals our window rect.y. Next off, we want to see if the click is on top of the input label, then it will return the associated input, and we say if input node rect dot contains our position, then the return value is our input node, and our input node equals to null. So if there is a curve attached to a node, if the user clicks upon the input node inside our node, then it will take the curve out and break the connection between the two nodes, and finally we return the red value. And now we want a function that is called when the window is clicked during a transition. So if the click happens on top of an input label, it will associate the passed node with that input. And the way we do this is by public override void send input, and as you see here, it passes the stuff we already need because it inherits from the base node. It passes the base input node input, a vector to click position, but we don't want to pass this, so we simply say click position.x minus our window rect.x, click position.y minus equals our window rect.y. You know what this is, we do it over here also. There's a lot of copy paste actually over here, so we'll be doing the same stuff a lot of the time. So if I miss something, I probably have explained it before. So we check once again if our node rectangle contains the click position, and if it does, we put our input node to be equals our input. So that's it for our input node or our output node. Next up, let's do our calculation nodes. Let's delete this. We need the namespace of Unity Engine. We want this to derive from base input node. So our variables for our input nodes, which is base input nodes input 1, private rectangle input 1 rect. Copy and paste that and change the input 1 to input 2. Now we want to say what calculation we want, so we make an enum. I'll call it calculation type and add addition, subtraction, multiplication and division. Of course we want to be able to change that, and we cast it as a variable with private calculation type calculation type. As before, we pass the constructor with a default value for our window title, which we'll call calculation node, and we say that it has inputs. Next, we pass our abstract class, which is draw window. We pass everything from the base class. We check for events. We make a pop-up which we cast as calculation type, and we do it the same as before by calling editor. Where is it? Editor GUI layout dot, for some reason gives me trouble, so I just copy paste this. We pass calculation type and we give it a calculation type variable. We want something to visualize our input, our first input result, and we pass the string input title 1. We simply say if input 1 title equals input 1 dot get result. We draw a label GUI layout dot label input 1 plus our input 1 title. If e dot type equals event type dot repaint input 1 rect input 1 rect equals our GUI layout utility dot get last rect. So it's the same, it's exactly the same as we did into our previous nodes, and for our input 2 it's actually going to be the exact same. So copy paste all that and change input 1 title equals none, input 2 input 2 input 2 input 2, because there is a lot of copy pasting. Take care to not leave the same value, because you will have problems later if you do the same. Let's just make sure we have everything correct. So that's it with this function. Next off, we want our public override void set input, and of course we pass base input node to be call it input, vector to click position. We pass the same as before. We change from global to world to local, and we will simply say as above as the output node, but instead of the output node we do a check for our input 1 dot rect. If contains the click position, then our input 1 equals the input. If not, and it contains the click position is contained inside our input 2 rect, then the input 2 is our input. Next we pass our draw curves, and we say if input 1 rect equals window rect dot x is input 1 dot rect dot x rect dot y plus equals input 1 rect dot y plus input 2 rect dot height division by 2 rect dot width equals 1 rect dot height equals 1, and node editor dot draw node curve input 1 dot window rect, and we pass the rect. That's it for input 1. For input 2 it's exactly the same as input 1, only we change the 2. I copy paste this from my cheat sheet, so we are sure that we don't have any errors. So just copy paste this and change every 1 to 2, and it's going to be the same. Next off, we want to pass the results. This is going to be a string, of course. Delete that, and we call it get result. Now we need a float input 1 value, we pass it a 0. We need a float input 2 value, we also pass it a 0. and we will say if input 1, we get the result inside a string which we will call input 1 row, and we pass the input 1 result, and we try once again to make it into a float. So for input 2 is exactly the same, so copy paste all that simply and change every 1 to 2. By default our result will be false, and we want a switch statement over here, and we will say our calculation types, and our first case will be addition, use break. Our second case will be division, break. Our third case will be multiplication, break, and our last will be subtraction and break. And inside this we simply pass the math behind our calculation. So for addition we take the input 1 value and we add it to the input 2 value and we pass it as a string. For division it's the same, but we do a division. For multiplication it's the same, but we do a multiplication. For subtraction we do the same, but we subtract one value from the other. And lastly we return our result. We want to pass our abstract classes. Oh, say base public override base input node clicked on input vector 2 position. Our base input node ret value equals null, and we say if input 1 dot rect dot contains pos, but of course we forgot to make our position from global to local, so just copy paste. It's the same as here, not as here. Where is it? So anyway, it's the same as we did before. Let's move on. And if the position contains inside the first input rectangle, the return value is the input 1. The input 1 equals null, else if input 2 rect dot contains the position, return value equals input 2, and input 2 equals null, and we pass the return value. Next we need to pass the node deleted, which is exactly the same as before, only we make two different if statements, one for input 1 and second for input 2, and if it's the same we nullify our inputs. This is it for the calculation node. We have one more and then we will go to create our node editor. So let's open up our comparison node, and there is an error. Let's see why. Our calculation type probably had an error somewhere. It should be okay now. No. So let me just copy paste from my cheat sheet. And this should be correct. So let's go to our comparison node. We want this to inherit from base input node. We want to add the Unity editor namespace. We don't want this. We want to set what comparison we want to have. Greater, less, equal. We make a private comparison type, comparison type. Our variables for our inputs. Let me just copy paste that because we're running near an hour. Base input node, input 1. It's exactly the same as our calculation node actually. Next we want a string for our result, or for our compares text. Next we want to do the same as before, comparison node to our constructor. We give him a default name, we pass our abstract classes, which is draw window. We add what we have already passed from the superclass. Now, same as before script, as the other scripts, we pass the event, we pass the comparison type. Actually, let me see over here. Yes, we do the same for our nodes as we did in the previous script. We pass the event, we pass the enum pop-up so the user can select what kind of comparison he wants to make. We pass the title. If we have an input node, we pass the result from the first input node. We make a label so we can visualize that, and if we have a repaint event, we populate the first input 1 rect with the get last rect. And for input 2 we do the same. We pass the default value of none. If we have an input 2, we pass the result of the input 2. We create a label and visualize the result, and if there is a repaint event, we pass the last rect of this. Now, same as before, we copy paste, public override void set input, base input node input, vector to click position. We convert from global to local. We check if the click position is inside the first input rectangle. If it does, we pass the input 1 the input. We check for the second input rectangle. If it contains the click position, we pass to the second input the input. And now we want to change our result. We do a public override string get result. Delete that bracket. We want our values first, and same as before, we check if there is an input 1. We try and make it into a float. If there is an input 2, we try and make it into a float. The default value for the result is false, and then we create a switch statement with our comparison type, and we have the case of equal, the case of greater, and the case of less. And inside here we simply do the checks. So the equal, if input 1 value equals input 2 value, the result is true. For the greater, if input 1 value is greater than input 2 value, result is true. And for less, if input 1 value is less than input 2 value, the result is true. And finally, we return our result. And same as before, we passed the nodes for the deleted, which is the same as we did over here. And next, we want to pass our base input node clicked on input vector 2 dot vector 2 position, and it's exactly the same as we did so many times before. Return value, we want to be a base input node. We make the global position into a local position. We check if the first rectangle contains the clicked position. Yes. If it does, we pass the return value the input first, and we nullify the input one of this node. If not, and there is input, the click position is inside the input 2 rectangle, the return value is the input 2, and we nullify the input 2 of this node. And exactly the same as before, we copy paste the draw curves, which is the same as this from the calculation node. And that's it for our nodes and the different types of nodes we have. So now let's go to our node editor and let's start actually visualizing all this stuff. First we want a list of base node, which we'll call Windows equals new list base node, a variable for our mouse position, a variable for our selected node, a boolean that it will help us determine if we are in transition mode or not. We initialize it as a default value. So in order to be able to access the window from the menus, we simply add a menu item, and this is going to be under window, and we just call it node editor, and beneath that we call a static void, so editor and node editor equals node editor will equal editor window dot get window node editor, and then we call the onGUI function. We check for event with event dot current. We store the mouse position with e dot mouse position, and then we will start adding our logic. So if there is an event of a button, and which equals 1, so there it's the left click, the right click, and we're not inside make transition mode, we check the event type, and if it is mouse down, we want a bool that will help us if we click inside a window or not. We initialize it by false. We need an integer to help us determine our index. We give it a default value of -1, and then we check with a for loop, which integer I equals 0, I less than windows dot count I plus plus, and for each window we say if windows I window rect dot contains the mouse position, which means if we right click inside mouse inside a node window, our selected index will be the I. we clicked on window, so clicked on window equals true, and we don't have to search inside the list anymore since we already found that we have clicked a window. So outside of our for loop, we say if we haven't clicked on the window, we create a generic menu, we will call menu, and we initialize it by using new generic menu, and then generic, then menu dot add item. But before we do that, we actually let's make another function just for so we don't get errors. It's going to be a simple void. We will call it context callback, and this will take an object, and we just simply call it obj right now. Let's go back where we were. Menu dot item. So and the item we want to use is new GUI content add input node false. We call for a new function and we pass an obj, not context menu. We want context callback, context callback, and we pass the string of input node. Next, we want a menu dot add item. Actually, let me just delete that and let's copy paste 4 times. The second will be an output node false context callback. We call it to output node. The third will be calculation node false context callback calc node, and the last one will be comparison node, and let's call it comp node. And then we want to visualize this, so we call menu.show as context, and then we want to consume this event by using e.use. Now, if we have clicked on a window, we still want a menu, but the item we will call is going to be make transition false context callback, and we change that to make transition, and the last one is going to be delete node, and we pass the string of delete node. But because it's a little close, so let's eliminate some errors, so let's add a separator between them and just call it, just give it an empty value. Let's copy paste since it's the same. We want to be able to visualize this. We want to consume the event. So after that, if we are in transition mode and there is a left button over here, we'll say else if e.button equals 0, ne dot type equals event type dot mouse down equals make transition mode we want to do the same as before, so take all this and copy paste that. So we find if there is a mouse input over a window. So if there is a click on a window and it's not the window that the transition started from, so if we don't click the same node and we say this, if clicked on window and not Windows selected index dot equals our selected node, then we call the set input on the selected window in order to evaluate if the selected node will be used as input. And we do this by Windows selected index dot set input. We cast it as a base input node. Selected, we pass the selected node and our mouse position. Make transition mode equals false. Selected node equals null. Now if we didn't click on a window, if not click on window, make transition mode equals false. Selected node equals null. So if the user clicked outside of a node window, we just simply disable our transition mode, and in the end we consume the event. But if there is a left click and we are not in transition mode, else if e dot button equals 0 and e dot type equals event type dot mouse down and not make transition mode, we do the same as before. We check if we have clicked inside the window, and if we clicked inside the window, we evaluate if the input of a node it was clicked, and we simply call for base input node to change equals Windows selected index dot clicked on input mouse pause and if node to change it's not equals null, we set that node to as the node to change, so we enable the transition mode once again. So if the user clicked inside an input node, then the curve will be under the mouse, and the previous node, it's going to be the selected node, and it's going to be inside the make transition mode. So if we are in a transition mode and there is a selected node, and that goes here, you will say if make transition mode and selected node not equals null, then draw the curve to the mouse position dot text and mouse position dot y, and we give it a 10 and 10 and close it, and then we call draw node curve selected node dot window rect and mouse rect, and finally we just do a repaint. Now for each base node we have in Windows, we call the draw curves function, and we start by drawing the actual windows. So we call the begin windows and we close it by end windows, and inside here we will just use a for loop, and we'll say for I equals 0, I less than windows dot count I plus plus, and windows I dot window rect equals GUI dot window I windows I dot window rect. We pass the draw node curve windows I dot window title, and that's it for this function for our own GUI. So let's make another void which we will call draw node window. This will pass an integer ID. Draw node window. Here we want instead of draw node curve, we want draw node window actually. So fix that, and we will say Windows ID draw window, and we want to be able to drag those windows around, so we simply use GUI.drag window. Simple as that. And now we can actually go into our context callback and make what happens when we right click and select something. We will need a string which we'll call CLB short for callback, and we'll say the object we are passing to this function, make it into a string, and we will say if CLB dot equals input node, then input node equals new input node. We cast a new node, we make a new node, our window rect is a new rect which we want to be at the mouse position dot x, mouse position dot y, and the size of our window we give it a value of 200, and let's just give it the height of 150. And finally we add it to our list and say windows.add input node. So else if, let me just CLB dot equals output node. These are case sensitive with this. Okay. And what we are doing over here is almost exactly the same as above, but let's just code them ourselves so we are sure there are no problems. Output node equals a new output node dot window rect equals new rect mouse post dot x mouse post dot y 200, and let's give this a height of 100. Windows dot add output node, else if CLB dot equals calculation node equals new calculation node dot window rect equals new rect mouse post dot x mouse post dot y width of 200 height of 100. Windows dot add calculation node, and finally else if CLB not actually finally CLB dot equals comp node, and we'll say our comparison node equals new comparison node the window rect of this comparison node will be a new rect mouse post dot x mouse post dot y 200 100 windows dot add comparison node. So this is for just our windows. Let's add the others the other stage, which if it's a transition, and we'll say CLB equals make transition and we say bool is actually the same as above as this, so we just copy paste this, so it will save us some time. We are nearly 1 hour and a half. So okay, it's the same. The boolean, there are variables we help. We check every window and see if we click inside the window, and we say if we clicked on window, the selected node equals Windows selected index make transition mode equals true, and then one last else if CLB equals delete node. If you noticed, we don't straight up compare with if statements. We don't use equals. equals, but we use this equal because if we put this into a different compiler, you might get errors, so we just use this instead. Let's copy paste the same. So we check if there is if we clicked inside the window, and if we clicked on window, we pass the base node dot selected node equals windows dot selected index, and we remove with remove at selected index. Then we pass for each window we have for each base node, and we inform that this node was deleted, so delete everything and every curve this node we had. So here we use else if statements instead of a switch, because selecting from a set of multiple cases is faster with if statements than it is with a switch. And finally, the only thing we have to do is actually draw the curve, but before we do that, let's make sure we have the same. Okay, they look the same, so that we don't get errors later. Because it won't, if it's not the same as above, it won't actually give an error. So let's double check. So let's start to actually draw the curve. Vector 3 start position equals new vector 3 start dot x plus start dot width divided by 2 start dot y plus start dot height divided by 2 and z of 0, vector 3 and pose equals new vector 3 and dot x plus and dot width divided by 2 and dot y plus and dot height divided by 2, z of 0, vector 3 start equals start position plus vector 3 dot up vector 3 dot right multiplied by 50, vector 3 and tangent equals and pos plus vector 3 dot left multiplied by 50. We give you a color, and don't worry about this, I actually found this in the forum, so I don't take credit for this. And color, we want to have a slight tint, so we just give it 0.06, and for int I equals 0, I minus 3, I plus plus, and we actually call handles dot draw Bezier start pose end pose and pose start done and done. Shadow color, we pass shadow color, we don't want to pass a texture, and we pass the eye +1 multiplied by 5, and after that we call handles.draw Bezier start toss and pause start done and done color dot black null, and we pass a width of 1. So that was for the shadow. That's for the actual curve. Now Ctrl S to save over here, Ctrl S to save over here. I'm doing it for each case because I noticed there was a slight bug that if I save over here sometimes it didn't save the other scripts, so I just go in every script and hit Ctrl S. So just to be sure, let's close that. Let's see what errors do we have. No, we didn't use inside our calculation node, instead of a Unity editor we use a Unity engine, so it couldn't find the editor GUI layout. First this, and calculation type, we actually have something subtraction, how was it? Calculation type top subtraction, I've wrote it wrong. Anyway, let's see. Yes. We pass it as a we need to pass it as a string instead of a variable, and to our comparison node also, and now it should be fine. Yes. Window, node editor, and here is our node editor. If it starts small, just open it up, and as you can see, if we right click, add input, right click, output node, calculation node, comparison node. If we put a value of 5, let's just rename this. Let's call it base attack. We want to give a number. Let's give him a base attack of 60. Let's add the calculation type. Right click, make transition. Let's add it to our calculation node. Let's add another input. Let's call them attack penalties. We'll give it a number. Let's say our warrior is a little tired, so it will have a 20 penalty into attack. Let's make transition. Let's put it into our different calculation node. Let's change this to subtraction. Now if we make the transition to the output node, it will give us the result, which is 40. Let's leave it there, and we want a comparison node. So let's add another input. Let's call this chances, and we want a randomization. We once again give a value of 0, and we pass the 100, so we get the value from 0 to 100. We make a transition to the input 2. We make a transition from the calculation node to the input 1. As you can see, it doesn't matter, it can go into another inputs, not just one. And finally we just want another output node, which we will call did the warrior hit. Hit enter. Let's make a transition from our comparison node into our input. Right now it says true, but our input 2 doesn't have a value because we need to hit calculate random. And as you can see, our comparison is greater. So if the base attack, which is 60, minus the attack penalties, which right now it's 20, this give us 40, and this 40 we compare it to the chances we have, and we get the result over here, which right now 49 is greater than 40, so our warrior didn't hit, so we get the result of false. Let's make another random, and it's still false. It's 73, 65, 49, it's all false. And here we get the chances of 16. 40 of course is greater than 16, so the warrior landed the hit, so it's true. In later videos we will see how we can actually utilize all this stuff inside our game and how it will actually affect objects inside the game, because right now we just get the result. And as you can see, if I click on an input, I can move it and move it elsewhere. The curves move them and put them into another node. If I click somewhere there is no node, we stop being in transition mode. If I right click and hit delete, it deletes the node and it actually gets it from our logic. So that's it for this video. This was a lot of stuff and a lot of advanced stuff. So I'll see you next week. Don't forget to subscribe, like, or whatever. And next week we'll do more cool stuff with Unity 5. So thanks for watching.